Thanks, Anthony. All right, welcome everyone. Thanks for tuning in. So tonight I'm going to talk to you, obviously, as Anthony said, about reptile reproductive disease, and it's one of the topics that we see a lot in clinical practice with reptile medicine. It's something that I would see on a kind of seasonal basis, so I think spring is a good time to be covering this topic, because in the next few weeks, as the days lengthen and the temperatures rise, reptiles are noticing that even though they're in controlled environments indoors, controlled by their keepers, they are noticing that it is springtime and there's reproductive changes going on. So when we talk about reproductive problems, I've categorized them into kind of four main areas in reptiles that we see in the clinic. The number one would be calcium disorders, and that's maybe a surprising one to class as a reproductive disorder, but calcium metabolism and calcium homeostasis in reptiles is a very large topic and causes a lot of problems and a lot of confusion amongst vets and amongst reptile owners. So calcium is really intrinsically linked with the reproductive cycle in reptiles, and also intrinsically linked with husbandry and nutrition, which are two of the main factors that end up leaving a reptile in need of veterinary treatment. Most of the problems that I would see would be linked to husbandry or nutrition, and calcium often has something to do with that. So as I say, it is quite linked to the reproductive cycle and reproductive disorders as well. So we'll touch on that a little bit at the beginning, and then we'll get into the more specific conditions. The next category we talk about would be dystocia and egg binding cases. So dystocia, obviously difficulty giving birth. Egg binding, we're going to try and distinguish and equip you with the skills to distinguish in clinic about the two different types of egg binding that we generally see, how they can be diagnosed, how they can be treated, and what we can do to prevent them in terms of our advice to the reptile keeper and client. And then we talk about prolapses, which are again reasonably common in reptiles. In females, oviduct prolapse and cloacal prolapse in both sexes, but also hemipenile and penile prolapses and the differences in treatment with those conditions. So as I say, reproductive problems I've classed as four main areas, and if we look at the top 10 common problems that I talked about in my last vet webinar, we see that in the top 5 we've got metabolic bone disease, which is intrinsically linked with calcium disorders, egg binding and reproductive problems, and prolapses. Those three areas are in the top 5 of the top 10 common problems we see in reptiles. So we're starting with calcium disorders, and the two sort of conditions we need to distinguish between and talk about are metabolic bone disease and hypocalcaemia. And they are two distinct, states of health, but they are completely linked, and generally hypocalcaemia leads to metabolic bone disease. But we'll talk about the differences between the two. The reason that calcium, as I say, is so important and is so linked with reproduction, particularly in female, reproductively active female reptiles, is that the initiation of the cycle that we're going to see in the next couple of months in reptile breeding season starts with the production of eggs or production of follicles on the ovaries, and that process called vitellogenesis really has high calcium demands. It's under the influence of estrogen. It mobilizes calcium reserves from the blood and from calcium stores in the body, namely the skeleton. And if there is insufficient calcium in the diet, or if lighting is suboptimal, and there's any disorders in the calcium pathway and vitamin D3 pathway, then we will see problems with hypocalcaemia, and in the long term we can see problems with subclinical or chronic metabolic bone disease over time as well. And if we have a reproductively active female that is preparing to breed, sometimes these conditions can be exacerbated and cause acute illness, and that's when the reptile will present on the consult table. So the demands of egg production and even fetal production in live-bearing species are absolutely huge in terms of calcium. So these reptiles have to have a good calcium reserve in order to reproduce properly. That reserve can be depleted very, very quickly at certain stages of the reproductive cycle, and you can have an acute hypocalcaemia, and you can have subclinical metabolic bone disease that results in an acute hypocalcaemia at a certain point in the reproductive cycle. So as I say, reproductive females are extremely prone to these two disorders for that reason. So we touch a little bit on metabolic bone disease. Anyone who tuned in November at my last vet webinar would have seen this slide. Metabolic bone disease is basically softening of the bones or poor bone calcification. So you get osteomalacia of the bones in order to maintain circulating calcium levels, and that can be due to a vitamin D3 deficiency if the reptile is receiving inadequate UV lighting. UVB in particular, the action of UVB on the skin promotes the synthesis of vitamin D, which allows calcium to be absorbed from the diet. So any step in that pathway, whether it's taking out the UV light or the UV light not being the right intensity for that particular species that's kept, or whether there's dietary deficiencies in calcium or even vitamin A and D that are provided in the diet, those kind of steps, any one of those can cause a problem with calcium metabolism. And if that animal is chronically deprived of calcium or can't absorb the calcium it's given because of these husbandry issues, then eventually will start to resorb calcium from the bones. And what we see on a typical case of metabolic bone disease on a radiograph, it hasn't reproduced perfectly in this presentation, but you can appreciate that the digits, the extremities of the animal are a little bit washed out and radiolucent compared to the axial skeleton, the skull and the spine. And also if you look on this leopard gecko's tail, you should be able to see, transverse processes on each of the caudal vertebrae, and those tend to disappear in the kind of stages of metabolic bone disease where you're seeing radiographic changes. So there are two things which are quite diagnostic for metabolic bone disease on an X-ray that you take. Look at the density of the digits, look for the transverse processes on the caudal vertebrae if it is a lizard, and if they're washed out or radiolucent, that's a good indicator that the animal is resorbing calcium from its diet. Another thing to mention would be a calcium-phosphorus imbalance, which is a kind of feature of a lot of the captive diets we provide, especially to insect-eating reptiles. Insects are quite high in phosphorus, so ideally we need to be supplementing those insects by feeding them a nutritious diet or gut loading the insects before we feed them to the reptile. And also we need to be dusting those insects with a calcium supplement nearly every feed, really, depending on what species we're feeding. So that can lead to metabolic bone disease as well. In terms of clinical signs, it's quite a range of clinical signs from very, very early stages of subclinical disease right through to the, totally collapsed animal that comes in a horrible state and the changes are irreversible. So clinical signs range from subtle things like anorexia or weight loss to lethargy. Then you see more kind of acute signs like weakness, tremors, muscle fasciculations due to low calcium levels, lameness or an inability to move properly. So you'll often get a plantigrade animal that can't support its body weight because the bones are softening and it's dragging itself along on its legs like this gecko was. And then we get to reproductive conditions. So the two conditions that I'm going to talk about at length in a little bit would be pre-ovulatory stasis or follicular stasis, often a consequence of an animal being in subclinical metabolic bone disease or being hypocalcemic in the follicular phase of the reproductive cycle. And then dystocia as well, if that animal has produced a clutch of eggs, let's say, and it's exhausted its calcium reserve from its skeleton and it's got acute hypocalcemia when it's about to lay, then that animal can very easily become egg-bound at that stage. The other things we would see would be more dramatic, like pathological fractures, scoliosis of the spine and tail, soft shell in chelonians, tortoises and turtles, and classic rubber jaw, which you can see in the bottom picture here, the mouth of a lizard sort of hanging open a little bit, and if you press it, the mandible will actually fold or deform with digital pressure. So, as I say, the clinical signs can be more subtle with hypocalcemia. They can be similar to kind of advanced metabolic bone disease, or they can be the same. In acute cases of hypocalcemia and reproductive disease, this is something that we can treat quite well in clinic over the course of a couple of days. Even over the course of 24 hours, you can make a significant difference if that animal has entered acute hypocalcemia. In terms of reversing the changes of metabolic bone disease, if it is advanced, those changes or corrections that we make are a lot more long-term, and you need to distinguish between what's happening